There is a simple relationship between the graph of a relation and the graph of its inverse. And this is going to be very useful to us going forward in figuring out what the graphs of various relations look like. Remember that when we take the inverse of a function, effectively what we do is to reverse the x and y coordinates. If we want to take the graph of the inverse, we do the same for the graph. So here we have the graph of a pretty simple relation. Right, in this graph, we have these three sort of key points. So we've got 3, 4, -2, 3, and we have -4, -3. To take the inverse relation, we take each of those pairs and reverse the x and y coordinates. So we'll have a point at 4, 3, -2, +3. Reverse the coordinates, we get 3, -2. Here's 3, -2. And then -4, -3. Reverse the coordinates, we get -3, -4. -3, -4 is right here. And then the rest of our graph is just connect the dots with those three dots. So we can draw straight lines connecting these dots. And we have the graph of our inverse relation. So if this is the graph of R, this is the graph of our inverse. And we notice that these have basically the same shape. It's just that the graph of R has been reflected across this line. This is the diagonal line where every point has the same x and y coordinates, right? This is the graph of y equals x. When we swap the x and y coordinates, points on that line stay where they are. Everything else reflects across it. So we notice that when we take the inverse, the graph is flipped across that line y equals x, right? That's the line where all of the points have the same x and y coordinate. And knowing that that graph is flipped is going to give us some guidance in copying the shape of a graph that has possibly a more complicated shape than just connecting dots with straight lines. So here we have a graph of a relation that's a little bit more complicated than just connecting the dots. This is the graph of the relation S, we're told. And while it's not just connecting the dots, there are some points on this graph that we can read pretty easily. We have the point -1, 4. We have -3, 1. We have -1, -2. And then looking along here, I think we also have a nice point down at 5, -5. So to get the points on the inverse, we'll just reverse the coordinates. So -1, 4 becomes 4, -1. -3, 1 becomes 1, -3. -1, -2 becomes -2, -1. And then 5, -5 becomes negative 5, 5. So we have these points, and we don't want to just connect them with a straight line, because the graph we're trying to copy doesn't have any straight lines. But we can look at the graph that we have, we can look at its shape, and we can look at that diagonal line, y equals x. So looking at that, we think, okay, well, this curve that goes around to the left, when I flip it, it's going to become a curve that comes down and then up again. And then does something like this to the right. Mirroring what it does at the top, and then stretches up toward 5, negative 5, doing something like this. So thinking about that reflection, got a better sense for what the shape of that inverse graph would actually be than we would have had if we only had the points.